Right, so welcome to tonight's lecture. This is lecture 12. It's supposed to be lecture 13. Yeah, so this is lecture 13. And we're still under functions. And tonight we're looking at the even and odd functions. And then apart from that, we also have to discuss how to find the domain, the range, and the domain and the range of different types of functions. Yeah, so let us quickly begin. So the first thing that you need to understand when you've been asked, or if they ask you to determine whether the function is even or odd, you first have to ensure that you test that function using f of negative x. So when you test that function using f of negative x, let me write it this side. If for instance, you've been given f of x is equal to maybe x squared plus 2x. Or before I do this, before I give you an example, let me first explain. So you test the function using f of negative x. So after testing that, if the answer that you get is equal to f of x, then the function that you've been given is even. And then if you test it, and then you discover that if you test it with f of negative x, and then you discover that the answer that you get is negative f of x, this implies that the function is an odd function. And then the other thing is that in case you test it using f of negative x, then you discover that it's not equal to f of x, it's also not equal to negative f of x. This implies that the function is neither odd nor even. This is what it means. So these are the three rules that you need to put in mind. So you can have a function that is even only when f of negative x is equal to f of x. Then you can only have a function that is odd if and only if f of negative x is equal to negative f of x. So what I'm trying to say is this. So I've explained this. I've also explained the second statement. Okay. Therefore, let us look at some of the examples. Okay, so let's quickly look at some of the examples. So the first example we have is determine which of the following functions are even, odd, or neither even nor odd. So these are the functions that we are seeing here. So the first one that we have is f of x is equal to 2x to the power 4 minus 4x squared, then plus 5. So we try to test, or we test it using f of negative x. So meaning we're going to put negative x where there's x in this function. So when you put negative x, we're going to have negative x there raised to the power 4 minus 4. Then we have negative x there raised to the power 2, then plus 5. So when you simplify this expression, so f of negative x, when we simplify it, it's going to give us, so negative x to the power 4, the answer is simply just x to the power 4. And then we have minus 4, and then negative x to the power 2, the answer is x to the power 2. Then we say plus 5. So you have to compare the first function that you have there with the answer that you found. So when you look at the value of f of negative x that you have found, this one is simply just exactly the same as the first function there. So if they are the same, it means that we can write that f of negative x is equal to f of x. So f of negative x is equal to f of x. And when you look at this expression here, This one is the one that we have there. So this implies that the function is even. Then let's go to the second one, which is just this one. So we also test this one with the same thing. So we find f of negative x. So f of negative x in this function, while there's x there, I'm going to put negative x. So I'll put negative x there, and then this is just going to be equal to the power 3. Then we say plus, we put negative x where there's x. So when you simplify this, f of negative x will simply just give us, so negative x to the power 3, this will give us negative x. Then x to the power, negative x to the power 1 to still, this one will give us negative x to the power 3. Then this one will be negative x. So we can write this, or we can simplify this to, so we say f of negative x is equal to, we can factorize the negative. So when factorize the negative, we're going to remain with x cubed plus x there. So when you look at this function in the brackets, this one in the brackets, isn't it exactly the same as that one? They are the same. So we can write this as f of negative x is equal to, I'm going to write this negative there. So I'll write the negative there, and then what is in the brackets there is exactly equal to f of x. So f of x is there. So I can write where there's that in the brackets, I'll put f of x. So when you look at this statement here, this one is just the same as what is there. Hence, this function is odd. It's an odd function. So you can have a function like this one, the last one there. So this last function, we also test it using f of negative x. While there is x, we're going to put negative x. So we're going to say negative x to the power 4 minus x. Oh, rather, we put negative x there. So negative x where there's x. So when you simplify this, f of negative x, this will just be equal to negative x to the power 4 will just give us x to the power 4. And then minus times negative x there, this will give us positive x. So here, do we have any way we can factorize the negative? No. Okay, let's try to factorize. When we factorize the negative, okay, we can factorize the negative, meaning everything will be negative there, which will not make sense again. So this f of negative x is not equal to the main function there. It's not equal to the main function. It's also not equal to, so we can say it's not equal to f of x. It's also not equal to negative f of x. Hence, this function is neither odd, it's neither odd nor even. So here is the key. When you have a function and all the powers that it has are even, it means that it's an even function. So if all the powers of the given function are even, it means that that given function is an even function. If all the powers of any function are odd, it means that that given function is an odd function. That is just a key you can use to know before you even find the answer. Then if you have a mixture of even powers and odd powers, because this one is power 1, this one is power 4, which is even, this one is odd. Hence, the function is neither even nor odd because it has a mixture of odd and even functions. All right, hope everything is clear. Let me also put up some questions that may seem to be tricky a bit. So you can also be given a function like f of x is equal to the square root of x squared plus 1. So you also do the same for such functions. You test this function by finding f of negative x. So f of negative x, meaning you're going to replace negative x where there's x there. So you're going to have negative x there squared plus 1. When you simplify this, you still have x squared plus 1. So x squared plus 1 is equal to negative f of x. So when you find negative f of x and you discover that the answer is exactly the same, this one and that one are just the same. So this one is the same or it's equal to f of x, meaning the function is what? Is even. So you can also be given a function like this one, e to the power x squared. And then they ask you to determine whether this is even or odd. So you can also do the same. Find f of negative x. So meaning while there's x there, I'll put negative x. Now square that. So now simplify this, this will still come back to e to the power x squared. Hence, the function is even, because when you look at this one is just the same as f of x there. So f of negative x is exactly equal to f of x. Hence, the function is even. Okay, so let us quickly move on to the next part, the next session. Hope you don't have questions on this question. Okay, so let us.
May I have a question?
Okay.
That's yes. Where you are taking on that example, is it example 3, where it's saying f of x is equal to root square x squared plus 1 root 1
Okay.
there, where you took that negative after you simplified it, where did the negative go?
The negative.
I think I didn't follow. Yeah, I think I didn't follow there.
All right. So this one is f of x is equal to. Are you talking about this one?
No, where there is a root.
Or you're talking about the one that I wrote here? F of x is equal to
Yes.
the square root of x squared. There was a minus here or a plus?
Yes, there was a plus, but x had a negative. Yes, plus 1. It was negative x squared.
No. I think that you didn't just see it clearly. It was a positive. I wrote it as x squared. Yeah, even if it had a negative in front, it would still have been as an even function. And because when you replace negative x while there's x there, you have something like this. So f of negative x will be the square root of, while there's x there, I'll put negative x, and then this will be negative x squared, and then plus 1. So even after simplifying this, you still get the same answer, which is the square root of x squared plus 1. So f of negative x is still going to be equal to f of negative x is still going to be equal to f of x, because this part here is just equivalent to f of x there, which is equal to that.
Yes.
Yeah, so this is
my question now, where are you taking that negative?
this one here.
Yes.
When I say negative x squared, this one is just the same as negative x times negative x. So when I say negative 1 times negative 1, the answer is 1. Same applies to negative x times negative x. The answer, this negative and that negative will cancel. But when you multiply the two negatives, the answer is positive. So you get a positive x. But of course, since you have x and x multiplying, we'll still have x squared. That's what it means.
Okay.
Yeah.
All right.
So, yeah, so that's the most important part there. Okay, so let us look at how to find the domain of a rational function and the range of any rational function, and also the domain of absolute value function and the range. We also look at the third part, which is just the domain of the domain and the range of a radical function. So in case I forget to explain about the radical part, you can remind me. Okay, so the domain, the way you find the domain of a rational function is, the first thing that you need to put in mind is a fraction should always be such, it should always be for rational numbers. Remember what we said. We said a rational number is a number that can be expressed in the form a over b, where a and b are members of integers, and then b should never be equal to 0. So I'm looking at this part. B should never be equal to 0, meaning the denominator should never be equal to 0. So once the denominator is equal to 0, it means that the function becomes undefined. So what do we do now to exclude values of x from the main domain, so that the numbers that we're going to put in this expression are going to make the function defined? So we're going to equate the denominator to 0. So we're going to say, let x minus 1 be equal to 0. So we solve this equation and find the answer. So we're going to have x is equal to positive 1. So x is equal to positive 1. So this positive 1, when you replace it there, you put it there, you discover that the function will be undefined. Hence, the domain of this function can be all real numbers. So we can say all real numbers, excluding 1. So if you want, you can say all real numbers excluding 1, or you can write it in set beta notation. You say the domain is simply just equal to x, such that x is a member of real numbers, but x should never be equal to 1. You can write it in that format. Yeah. So, and then if you want, you can write it in interval notation. You say x is equal to, you write all numbers starting from negative infinity up to 1. Of course, 1 is not supposed to be part of the set. And then you say union, open at 1 again. 1 is not part of the set, and then close, and then positive infinity. So this is how you can find, these are the 3 ways you can write the domain. We have the descriptive part, we have the set beta notation, and interval notation. So you can write it in that way. So that is the domain. Now, how do you find the range? So to find the range, you first have to understand how to find the inverse of a function. So how do you find the inverse of any given function? That is a simple and straightforward thing. You first remember what we discussed in the previous session. We said you equate the whole function that has been given to y. So you say let y. So this is the domain. We're now finding the range. So we say let y be equal to 1 over x minus 1. So we make x the subject of the formula. So I'm going to cross multiply there. I'm going to have y times x minus 1. Then this is just going to be equal to 1. Then y times x, this will give me xy. Y times 1, this is y is equal to 1. And then I'm making x the subject. Hence, I'm going to take this y to the other side of the equal sign. So this will be xy is equal to 1 plus y. And then, since I'm making x the subject, I'll divide by y. And then I'll divide by y there. So the value of x will now become 1 plus y over y. Therefore, f inverse of x will therefore be equal to 1 plus x over y. So to find the domain, rather to find the range of this function, remember we are finding the range. I'm emphasizing on this one because a lot of people get confused. We are finding the range. So now the way it is that the range of an inverse function of any given function is equivalent, rather the domain of any, okay, let me make this clear. The domain of the inverse, so the domain of the inverse of any function is equal to the range of the original function. This is what I wanted to say. So when I find, I'm supposed to put x here, not y, because I've changed everything. Where there's x, I'm putting now, rather where there's y, I'm putting x. So if we find the domain of this function, it means that that is the range of that function. So the domain of this function is the range of that function. So what is the domain of this function? So to find the domain of a rational function, we said we have to equate the denominator to 0. So we're going to equate x to 0. Hence, the domain is going to be all real numbers, excluding all real numbers, excluding x is equal to 0. So all real numbers excluding 0. Or you can write it as a set builder notation, where you can say x is such that x is a member of real numbers, but x is not equal to 0. Yeah, so that is the range of this function. Okay. I hope everything is clear. Let me give you another example on this one. So we can have another example as, let's say you have x, you have f of x is equal to x over, you have x over x squared minus 4, x squared minus 4. So for this one, we find the domain. So finding the domain of any given function, we just equate the denominator to 0. So we're going to have x squared minus 4 is equal to 0. So take this negative 4 to the other side of the equal sign. So this will be x squared is equal to 4. So we find the square root on both sides. So the square root of 4. Of course, this one will be plus or minus. So we're going to have x is equal to plus or minus 2. So this is what we're going to have. So now, after finding this, it means that if we are now to write the domain in set builder notation, we can write it as, in set builder notation, we can write the domain as x such that x is a member of real numbers, but x is not equal to 2, and x is also not equal to -2, because we found two answers here. We have x is equal to 2 and x is equal to -2. So this is how you can write a domain in set builder notation. Or you can write x, you can just say the domain is equal to all real numbers excluding 2 and -2. Because when you put 2 here or you put -2 here, this function will be undefined. That's what that means. So we don't want anything that will make the function undefined. All right, so let's find the range. So now the question is, how do you find the range? So the range is found by, okay, so the range is found by equating this equation to y. So we're going to say y is equal to, so we're going to have y is equal to x over x squared minus 4. And then from there, we can make x the subject to the formula. So you're going to have x, let me say y outside. Okay, I'm going to write it here. Y times x squared minus 4 is equal to x. So when you multiply there, you're going to have x y. You're going to have x squared 1 minus 4y is equal to x. So making x the subject to the formula in such an expression, this is a quadratic equation, is a bit difficult. That's what I can say. Yeah, but let us try. Yeah, let's try it. So we are going to bring this x on the other side of the equal sign. So we are going to have x squared y, and then minus x minus 4y is equal to 0. So trying to make this, x the subject of the formula here, is just the same as completing the square of this quadratic equation, which is just the same as using the formula method. Yeah, so if you want, you can just say x is equal to negative b. This will now be the coefficient of x there, which is just a -1. So negative b will be 1 plus or minus the square root of so plus or minus the square root of b squared, because the formula is like this: x is equal to negative b plus or minus the square root of b squared minus 4ac, everything over 2a. Then b squared there will be -1 squared minus 4. My a in this case will be y. Then my a will be y. Then my c will be -4y. So this is how it's going to be, everything over 2. My a is y. So just from this expression here, even before simplifying it, you can find the domain, or rather, you can find the range. So we can say x is equal to 1 plus or minus the square root of 1 minus, so this would be a plus 4 times -4 times -4. This would be a plus 16y squared, then everything over 2y. So the inverse will therefore be equal to, so this f inverse of x will therefore be equal to 1 plus or minus 1 plus or minus the square root of 1 plus 16x squared, and everything divided by 2x. So let us find the domain of this function. The domain of this function is going to be the range of the main function. So the domain of this function will just equate the denominator to 0. So I'm going to say 2x is equal to 0. So the value of x is equal to 0. So the domain of this function, which is just the range of this, hence we say the range of the function f of x is equal to x such that x the member of real numbers, but this x should never be equal to 0. So that is the range. Do we have any questions, or I'll give another example? Okay, let me give the last example.
Another example, me, I'm lost completely.
All right.
Lost completely.
Okay. All right, so let us get another example. So the example we're going to have, it will be a bit simple. So this one is just going to be, okay. So for this one, we're going to have, okay, let's say f of x is equal to, let me say 2.
The same question.
This same question? Okay, let me just
Do the same question.
Okay, 1 over x minus 1.
And
So
what are we finding in the simplest?
we are finding the domain and the range. So I said the domain of a rational function is found by equating the denominator to 0. So when you equate the denominator to 0, you are going to have x minus 1. So you have x minus 1 is equal to 0. And the value of x will now be equal to +1. So this +1 that you have found is not the answer. So the answer will now be written in either set beta notation or interval notation or descriptive notation of a set. So the final answer will now be written as the domain, because we're finding the domain. The question is find the domain. So the domain the domain will now be equal to, we know to say this number that we have found here, if we replace it there, when we put 1 here, we are going to have 1 over 1 minus 1. This will be 1 over 0. This one is undefined. It's undefined. So this is the situation we're trying to avoid. We don't want to have any number that is going to make this expression undefined. As a result, we're going to say the domain, remember what we discussed last time. We said the domain is actually the, so whenever I post any video there, make sure that you should be revising so that when we start something, at least you have a background of some knowledge. Yeah, so when you talk about the domain, these are just a set of inputs, or these are just values that we can plug in a given function, that we can put in a given function. So in this function, we can put any number excluding 1, because if we put 1 there where there's x, if we just put 1 there, the answer will be undefined. So here we can put any number, any real number, excluding 1. So this one that we have found is an exclusion from the domain. So the domain is just going to be x such that, so this x can be any real number excluding 1. So this x should never be equal to 1. That's why in the descriptive form, we can just say the domain is just, let me just write it here. You can say all real numbers excluding 1. That is how, that is the other way you can write this. So the domain is simply just all real numbers excluding 1. Now, the question is, how do you find the range? The range is simply just the set of outputs. So if you have f of x is equal to 2x plus 1, the domain, if I put
Sir,
in,
sorry.
okay.
No? Sir, sorry, just there before you proceed.
Yeah.
We are saying after finding that x is equal to 1, then when writing the domain, we are saying x is a member of real number, but x should not be equal to 1. And yet in the answer there, it is saying x is equal to 1.
Yes, that's why I said this is not the answer. This one is just telling us a number that's such that when we replace it there to give us an undefined function. So what we are saying is that a domain, okay, let me just start from the definition of a domain. If you have f of x as a number, rather as a function which is equal to maybe 2x plus 3. So if I say the domain is 1, 2, the set of the domain is 1, 2, 3, it means that I am going to be putting this 1, this 2, this 3 in this function there. So if I find f of 1, the answer will be 2 times 1 plus 3, the answer will be 5. If I find f of 2, the answer will be 2 times 2 plus 3, the answer here will be 7. If I find f of 3, this one will be 2 times 3 plus 3, this will be 6 plus 3, the answer will be 9. So now, what I was putting in this function is called the domain. Whatever that I'm putting, any number that I'm plugging into the function is called the domain. And then these answers that I'm finding this side, they're the ones that we call the range. So the range of this domain here is just 5, 7, 9. So this is the range. If this is the given domain, the range is going to be that. So now, having known what the domain and the range is, we can now find the domain of this function. So the domain of this function, we can just say all real numbers can be plugged into this function. So we can put in all real numbers in this function. But if we put any number, or if we put any number that is going to make the denominator to be a 0, we know to say any number divided by 0 is undefined. So we don't want to have this situation where we have a number, after putting it there, it gives us an undefined as the answer. So what we are going to do is that we are going to equate the denominator to 0. In other words, we don't want the denominator to be 0. So if we don't want the denominator to be 0, okay, let me explain it this way. So if we don't want the denominator to be 0, so we're going to say x minus 1 should not be equal to 0. Maybe this way you're going to understand. So x minus 1, which is the denominator, should never be equal to 0. So if we have such an expression, we can now say x is equal to, rather there's not equal to, so we're going to say x is not equal to, we take this -1 this side, we're going to have +1. So we say x is not equal to 1. So now to write the domain of this function, we can say the domain of this function, in this function here, we can put all real numbers that we know. We can put all real numbers there, but x should never be equal to 1. So while there's x there, we can replace any real number, but we should never make a mistake to replace it with 1. Once we put 1 there, we are going to have 1 over 1 minus 1, which will be 1 over 0. This is a situation that we don't want. So that is what it means when we say find the domain of any rational function. You just equate the denominator to 0. And then finding the range. To find the range of any function or any rational function, you simply just have to find the inverse of that function. So the domain of the inverse of that function is the one that is equivalent to the range of the main function. So what I mean is that if you find the domain of an inverse of any given function, the answer that you get is equal to the range of f of x of the main function there. So the link is going to cut anytime soon, and then I'm going to send another link that you will be allowed to join. So the domain of the inverse function is equal to the range of that given function. So what you just need to do is to find the inverse function of this given function here. So when you find the inverse, you are going to find the domain of that function. So that the domain of that inverse function. So if you find the domain of that inverse function, the answer that you are going to get is exactly the answer for the range of this function. That's what it means. Because if we say